Yep. Hi, everybody. My name's Ben Curran, and today I'm here to talk about working with LASData using LASDatasets.jl. Not entirely sure what the abbreviation is, actually. Sorry to spoil it. So to sort of give some context as to the history of this package, there are some really good Julia packages that do LAS data manipulation, particularly LAS.io has been a really good one. So I come from a geospatial company, Fugro, who does a lot of point cloud processing, and we required the latest version of the spec, which I'll get into details in a second, to be available, as well as some more bespoke features for our industry requirements for point classification. So that's kind of like the justification for why this package sort of came about in the first place, and we're definitely looking to collaborate with more people going forward. Yeah, so it would be great if you want to get involved. Just post an issue or send me a message. So today I'll be discussing, first of all, what is LAS, because it's not a very well-known data format, and also what the core features are of this package and some of the high-level interface going into it briefly, and then I'll make some comments on the future work. So LASData is a format of data file that basically allows you to store point cloud data. So the basic sort of layout of how that works is like, of the process of making a LAS file is like this. So you start out with an aerial scan where your plane is flying overhead and it's shining a laser beam down at the ground. And every time it reflects off something, you get these pulses of energy that we call waveforms. So there's some processing going from that waveform that I won't go into that basically then produces your point cloud, which is a set of three-dimensional points that each have attributes associated with them. So you take your point data and you can also attach things like georeferencing information from the plane, as well as some custom user data, things like dataset labels, and you basically pack that all up into a LAS file. So the LAS file itself looks something like this. And now so LAS is a specification for how to order this file, and it's gone through a few iterations. So the current latest version of this is LAS spec 1.4, which is the one that we provide support for in LAS datasets with some legacy formats as well. So it's split out into these sections. The first bit, obviously, it's a public header block. So this, like other files, stores metadata about the file contents. So you have things like file source information or byte offsets to different quantities. It then follows a set of variable length records, which are packets of data that are associated to the dataset as a whole rather than each individual point. So these things are useful for like coordinate system references, datasets, tags, etc. The spec also allows you to just kind of cram a bunch of extra raw bytes in between variable length records and the point records, so we support that too. And so the main bulk of your file is going to be in these point records. So a point record contains data for your points, obviously. So the LAS spec defines 11 point formats that you can support in this, and each point format is a unique combination of what I'll refer to as LAS fields, which are like properties associated to a point. So things like its position, its classification, its intensity, that sort of thing. And you can also potentially have some extra user fields inside this. So if you want to attach, for example, a cluster ID, you can do that as well. And then, as the name suggests, you also have extended variable length records, which are like variable length records, but bigger. So they're chucked at the end of the file, and they're useful for waveform data and other things. So what does this package actually provide? What value are we giving? First of all, we provide, as I mentioned, full support for the latest 1.4 LAS spec, as well as legacy support for some of the older specs. We also have a bunch of high-level functions for I/O and manipulating the properties of your point cloud file. So this is done at a very user-friendly level. There's a lot of functions that you can use, and the main focus of that is to make it as easy as possible for people to get in and start doing things with their point clouds. We also have a LASPy-like parsing of native Julia structs through your VLRs. So rather than having at the lower level to deal with the raw bytes of your VLRs, you can pass in native structs. And it also allows easy modification of header properties as well. So because of time constraints, I'm only going to kind of go into a high-level interface for like I/O, so saving and loading LAS files. So the basic flow looks like this. So the main function that you want when you're reading is load LAS, and that takes in some LAS file, and it spits out this LAS dataset, which is like the main struct this package exports. And it's got, you can see it's got all the information kind of relating to the LAS file structure. With a little bit of extra stuff. So a design point that we made while doing this package is that the LAS points themselves are actually stored in a tabular structure. This was deliberate because often when doing things like point classification at Fugro, we want to query point properties for like a big collection of points. So you can either iterate through each point and grab it, or you can grab it from the column of a table, which is much quicker. So we rely heavily on the type tables interface for this, and that kind of helps for performance reasons. We also store under the hood the LAS fields, your position and classification, etc., and the user extra fields, so like anything you add onto the points separately, and that kind of helps to optimize multi-dispatch under the hood. And then you've also got things like your header and VLRs that are also represented as their own structs in here. And then finally, you can just call save LAS on this whole object and specify an output file, and then, yeah, you basically got the whole workflow. So as a practical example, I'm not doing live demos for obvious reasons, but basically if you have an example.las file, you might want to call it, and you can also specify things like, I only want the position and the classification for each of my points. So that'll spit out this nice LAS dataset here, and it specifies the number of points, the point format, the point channels, which are like the properties for each point, as well as the number of VLRs, EVLRs, etc. And then nice and easy here too. Once you get that, you can also just save it to another file if you want. So you can save it out to a pc.las. It's all very quick and easy and high level. So you're not actually having to worry about pulling individual bits of the file out. It's all sort of done under the hood and then shipped off for you. A more practical example is if you actually want to do something with your point cloud, you can get it in a tabular format with this get point cloud function. And as you can see, it returns this table structure with each of your point properties in the columns. And you can do cool things like if you want to add another column of a user field to your points, you can add it as a vector. So you can say, I want to add this thing property to each of my points. That's a random uint16. And then once you add that, it'll modify it. So when you call get point cloud again, then it'll return, now you've got this nice thing column at the end, which is pretty cool. And one more thing that people will probably be interested in, you can also grab the VLRs out of your LAS dataset, and they're also exported as these LAS variable length records, which is basically the same as how LAS.io does it. And they're also parameterized by Julia native structs. So this will allow you to pass structs in and out if you want to. There's some extra details in the documentation if you're interested. So there's a few things that we want to work on to sort of make this package more streamlined and better. So one thing is point streaming. This is all currently done on disk, so obviously it's unideal when you get to the tens of millions of points. We also want to add full support for waveform data, which we don't currently have, and improved handling of compressed data. I also like to acknowledge the developers of LAS.io and the compressed version LASDatasets.jl, as well as Avid in the crowd, who's done a lot of work on this package and some of the other reliables. So if anybody wants to help collaborate, I'll just reiterate we're fully open to people helping out. Yeah, any questions?
Here's a round of applause. I may have missed this. Do you use memory mapping or do you copy the data into RAM?
I think we just copy it into RAM currently. The compressed version, I think, does it slightly differently, but yeah, it's all pretty much copied directly.
Compression, you copy during decompression, but if it's uncompressed, you could memory map.
Yeah.
And then if you have repeated calls.
Oh, yeah, we use buffered I/O streams, which are kind of similar. So it'll create a buffer and it kind of does a similar thing, but it was just, I found it was more performant than using memory mapping for whatever reason.
Okay.